go through the contents on regular basis and keep on practicing, then no problem. But here, at least minimum pass mark you must have here. So be careful from the very beginning, so that you do not face any problem to score minimum marks to be qualified. So you just don't worry. I will be available anytime. You can just don't hesitate to communicate with me whenever, whatever you face any problem related to this course. And today I just would like to share my screen. Just a fundamental topic, fundamental of mathematics, very basic of a topic, that is matrix. The matrix actually, you yeah, a panel is disturbing on the screen actually, and I am not too much computer savvy. Anyway, see the screen. Is it visible? The screen? Uh, is it visible? The screen?
Yes, sir.
Yeah. So okay. First of all, we should go through the definition. Matrix. Matrix is actually what it's just an arrangement of some elements. There is no restriction any what to write, what will be the elements, what will be the quantities, anything, and any expression might be there in their corresponding places. It's just an arrangement of some elements, some numbers. But that systematic arrangement is definitely will be there. That systematicity is in certain rows and columns. If you look at the screen here, three matrices I have taken here, that is A and B and C, capital C. If you observe in these three matrices, uh, you see here in the first A is the actually name of the matrix. It is basically matrices are denoted by block letters. So first one it is A, second one it is just denoted by B, and thirdly it is denoted by C. So if you look at here, it's just an arrangement of some numbers, some elements. In certain, if you observe carefully, they are arranged in certain rows and columns. In the first matrix, if you see here A, there are -2, -5. This is one row, that is first row. And in the second row, if you observe 0, √5. And third row, 3, 6. Horizontally, if we see the numbers, these are rows. These are rows. So there are 3 rows here. And vertically, if we observe, first is -2, 0, 3. So since it is vertical, so we used to term this as column. So -2, 0, 3, this is first column, and 5, √5, 6, this is second column. That means the matrix A consists of two columns and three rows. So that's why accordingly its structure is vertical, because number of rows is bigger than number of columns. So shape is rectangular, is vertical. And similarly, if you observe in the second matrix, that is B, here the first row, 2 plus I, first element, 3 minus half. This is first row. 3.5 minus 1 to the second row minus sorry root 3 5 5 by 7 is the third row, and similarly here three columns are here. So first column, if you observe vertically, that is 2 plus I 3.5 and root 3. This is first column. And in the second column, if you see that the 3 minus 1 5, and the third column minus of 2 5 by 7. So the matrix does B consist of 3 rows and 3 columns, and accordingly its shape gives us a square because of having same number of rows and columns. And so 3 rows 3 columns here. In the third one, C, if we observe, and first row 1 plus x cube 3, this is the first row, cos x sin x plus 2, single element, sin x plus 2, just an expression, second element, and tan x, third element of second row. So two rows are here, and vertically if you observe, three columns. First column here 1 plus x cos x, second column x cube sin x plus 2, third column 3 tan x. You know, in the matrix A, 3 rows, 2 columns, its shape is this vertical rectangle, and in B, 3 rows and 3 columns, so it's shape square, and C is number of rows 2, number of columns 3. So number of columns is little bit bigger than number of rows, so it's horizontal, rectangular, but it is horizontal. So accordingly, the shape of the matrices depends on the number of rows and number of columns, and it is mandatory to express this arrangement within third bracket as shown here, third bracket, or you can use first bracket. So to represent a matrix, if you write the elements in certain rows and columns, then the elements must be within first bracket or this third bracket. So this is mandatory. No any other bracket, any other vertical bar not allowed. Second bracket not allowed. Only first bracket and third bracket allowed to represent a matrix. Now, this is just an arrangement of some elements. I think you are clear that it's clear to you that it is just an arrangement expressed within first or third bracket in certain rows and columns. And it's a new thing, it is not value, it is just an arrangement. Which matrix is greater than the other? This question does not valid here. Here A consists of 6 elements, B consists of 9 elements, so we cannot say B greater than A because it's not overall an arrangement, so it's not value. So inequalities, that is greater than less than relation between matrices, it does not exist. In determinant, different issue, so we'll be coming in determinant when we'll discuss about determinant, that is little bit different. So simply a matrix, we have learned that it's an arrangement of some elements expressed in certain rows and columns within first and third bracket. Now what is order? Since it is a new thing for the new learners, so many characteristics, so many properties we have to discuss about this thing because it is not a value, not a number, not a simply expression. It's a pattern of numbers are there. So there are so many properties, characteristics, and types. So phase wise, very slowly, we will be familiar with this. So order of a matrix. Now, what is order of matrix? actually how many number of rows and how many number of columns are there? Number of rows and number of columns. This is simply we call order. So sorry, order of the matrix, if we observe, then number of rows and number of columns, number of rows and number of columns, here. So if we observe this matrix here, then it is general matrix. It is called general matrix. General matrix, here how many rows are here? How many rows are here? You see, this is first row, this is second row, this is third row, and dot 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 so on. This is mth row. And this is first column, this is second column, this is third column, and so on. This is nth column. That means here m rows are here. It is not specifically number is considered. The m rows is here and n number of columns here. So its order is written here m into n, but it is read as m by n. This first component represents the number of rows and second component represents the number of columns. It is, we are calling general matrix because no certain number of rows and columns shown here. It is just symbolically expressed in terms of m and n. So m rows are here and n columns are here. So order of the matrix is m by n. It is read as m by n. It is not m into n. Order is read as m by n. Let's see here in these examples. A. How many rows here? You see here 1, 2, 3. So 3 rows are here and 2 columns are here. So order of the matrix will be 3 by 2. 1, 2, 3. 3 rows are here and 2 columns. So order of the matrix will be 3 by 2. It is written as 3 into 2, but read as 3 by 2. And similarly here in B, in case of B, 3 rows are here and 3 columns are there. So order of the matrix B will be 3 by 3. Written as 3 into 3. Its order actually 3 by 3. Similarly, in the matrix C, 1 and 2. 2 rows are here. So 3 columns are here. So order of the matrix C will be 2 by 3. So simply order of the matrix we can say just knowing the number of rows and number of columns. So that means order of the matrix gives us actually shape of the matrix, because order of the matrix gives us how many rows are there and how many columns are there. So it is a general matrix. So here it is m by n, that is m rows are there and n columns are there. Now we observe, you can observe here, the elements are not considered numbers here. Elements are considered alphabetically, just A is considered and some suffixes considered here. If you observe carefully, then you can understand very nicely here. Here you see A, the first element A, its suffix considered A11. In the first row, if we see the second element, then it is A12. Similarly, in the third element, it is A13 and dot dot so on. That means next will be 14, 15, 16, 17 and so on. And somewhere it will be definitely ending, and that is considered as 1n. That means n elements are here in the first row. That means n columns. So n elements are here. If you observe here, suffixes, here it is, you see 1, 1, 1, 2, 1, 3, one any considered one j, that means one something, and last one n. In these suffixes, if you observe, first component remains same. Here it is 1, here is also first component 1, here is also first component 1, here is also first component 1, and here is also first component 1. This means first component indicates the first row. That is, first component indicates always row. That means in which row the element is lying. And if you observe that always first component indicates row. And second component, if you observe here, this is 1, and this is 2, and this is 3, and so on. Finally, it ends with n elements, n columns. So, this component, second component, indicates column. You see, this is 1, that means it lies in the first column. This is 2. In the second element, this is 2. So, that means this element is lying in the second column. Similarly, this is A13. It is second component is 3. So, it is lying in the third column. Similarly, any particular element, number z, so it is z column, and it is nth column, n number of column. If n is 10, then it is 10th column. If n is 15, then it is 15 column. So, you can understand about the suffixes that two components are there in all suffixes here. First component, always mind it, first component indicates the row and second component indicates the column. And particularly any element from this general matrix, if we pick up, then you see here, so suppose and this element, that means second row, third column, A element, that is A23. A23. If you observe particularly this element, you see here 2, 3. First component 2, second component 3. That means this element is lying in second row and third column. If you pick up any element, say here it is this one, last row, second column, this element. If you see here, it's AM2. So first component is M and second component is 2. That means this element is lying mth row, last row. If M is 10, then 10th row. If M is 15, then 15th row. So it is mth row and second column it's lying. So that means this is standard notation to write any particular element symbolically, to represent any element of a matrix symbolically. So it is very standard notation to represent, because its suffixes can indicate us actually in which particular column and which particular row the element is lying. So that is why this matrix, we can say it is general matrix. Any number of rows or any number of columns we can consider. That is, we can consider any m or any n. So that's why we call it is general matrix. And this matrix, general matrix, here it is symbolically we can write this way also. If the matrix, this matrix is denoted by capital A, then this general matrix we can write in this notation also. Whenever you go through any particular books, any particular book chapter, or through any internet searches, then you will be having in topic of matrix, these symbols definitely you will be having everywhere. So to be familiar with this, you must understand this. Okay, this A general matrix is represented by this. So this way also we can denote this Aij. This Aij represents all the elements. That is A1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 2, 3, 1, 3, 2, 3, 3. That's all elements. All these elements are represented by this simply Aij. I for row and J for column. So this represents all the elements. Now, these elements, all the elements, but what is the size of the matrix? What will be the order of the matrix? That's why within third bracket indicates that this is a matrix. Third bracket indicates that this is a matrix and its elements are Aij. Aij. I is row, J is column, obviously. But what will be the order of the matrix? So, order of the matrix is M and N. I indicates row, J indicates column, no doubt. But how many rows and how many columns will be there? It gives us by order of the matrix. So that's why M by N, the order of the matrix is written here. So this is the standard notation to represent a matrix. And Aij simply standardized to represent elements. These are elements, just Aij. These all are Aij. I is here 1, J is 2 here, I is 1, J is 3 here, here I is 2, J is 3. So Aij represents elements of a matrix. And when we represent like this, when we write in this way, Aij within third bracket, and besides this a suffix m by n, or that is order of the matrix, then this represents as a whole the entire matrix. Simply Aij represent elements, but if Aij expressed in this format, then it will give us a whole matrix. So here I and j, since I is the row and number of row is maximum m is the last row, that is number of rows is m, number of rows is m. So therefore the value of I cannot exceed m. So that's why with this Ij notation, this condition must be there in representation, because this m is the maximum number of rows. So that's why number of rows must be less than or equal m. And similarly, n gives the number of 1 minute. Just somebody is waiting here. Okay, okay. Similarly, the condition on n is this one: j must be less than n, because j indicates the columns. So maximum column is n here. So the value of j cannot exceed n. Some students are still trying. Actually, it is, as I told you earlier, it will be very disturbing. So I cannot take care of this type of issue during the session. So so that's why this condition is mandatory, because m and n, I and j here. So I and j definitely cannot exceed the value of m n, because I is row. So number of rows, maximum rows is m. So the value of I cannot exceed m. So it must be less than or equal m. And since I is the minimum row must be 1, so number of rows cannot be 0. So that's why it is the value of I must be greater than or equal to 1. Similarly, j also, number of columns, it is must be greater than or equal to 1. So this is the general matrix, and so we have learned what a matrix is. Simply, it's an arrangement of some elements, some numbers, some expression in first bracket or third bracket, strictly in certain rows and columns. And order of a matrix is number of rows and number of columns. Number of rows and number of columns uh, are given by the order of a matrix. Actually, size of the matrix is given by order of a matrix. So order of the matrix gives us how many rows and how many columns are there in the matrix. And representation of a matrix. So here in general matrix, as I have told you, the elements are represented by Aij and simply Ij, and general matrix is uh, denoted by symbolically Aij m by n. M by n means is number of rows and number of columns, order of the matrix. So a representation of elements with the suffixes a11, a12, a13 are very much important to understand any contents from any materials, or whenever you search anything from online, or any go through any particular chapter or books. It's okay. So do you want to ask anything here in this? Do you want to ask anything? Is it clear? Simply fundamentals. Or some students are not able to join here, uh, unable to join. I can't understand why it's problem, because all the students initially whoever joined. Hello, are you are you hearing? Rinky,
Sir?
are you hearing?
Yes, sir.
Yeah. So some students actually are unable to join. Did you get the message?
Yes, sir.
Uh,
I'm getting.
it's okay. I can't understand what's their problem. It might be a network issue.
Yes, sir. It might
So
be.
anyway, the students, you want to ask, if you want to ask anything, you can proceed, because time is very limited here. Mm. It's okay, no problem. But you don't worry that whenever the real classroom sessions will be started, as I told you last class also, when the real classroom sessions will be started, these will be repeated, and basically for the students having not mathematics in the earlier standard, it will be taking little bit more time to understand this. So that's why I'm going very slowly. No problem at all. Don't worry. Just you can communicate at any time, at any moment, regarding any class related issues. And just don't worry any regarding this paper. You can communicate. Okay. Fundamentally, just I have given just introduction of the term actually, not gone into depth. And some properties, types of the matrices will be there, some properties will be there, and some operations definitely will be there. How to add two matrices, how to subtract two matrices, how to multiply matrice two matrices. So with their properties, so many things are there to discuss. So gradually we'll be progressing in learning this portion, that is metrics related, um, all everything. And just as a introductory session, just clarified what a matrix is, and how it is denoted actually, and how its shape depends on the order of a matrix. It is very um, fundamentally I have given a touch. So please you do not late do not try to join lately because it will be very disturbing if it happens during the session, and so many technical issues might be there with your technical sets and network issues. So that's why so many problems, personal problems, technical problems might be there. So a few minutes, just few minutes before the session starts, you can try to join. Otherwise, in between the session, it is disturbing. It's okay. Okay. Thank you so much. Net slow.